this lesson, we're going to start talking about how we can find the horizontal intercepts by doing factoring. And in particular, we're going to talk about how to factor by grouping. And to get us started thinking about factor by grouping, it's a very common strategy when we have multiple terms and we want to essentially divide and conquer to think about how we can use the greatest common factor that we have been using before and now considering these common factor as more complex expressions. And once we're able to do factor by grouping for the factored results in order to find the horizontal intercepts, we can again set the entire expression equal to 0 and use the zero product principle to find out what x values would give us these 0 factors. And let's look at part A, for example. In part A, we already have naturally two expressions connected by this addition over here, and what I mean is the first part and the second part, they're both in the factored form, and we also have this connection of plus sign in the middle. And really we can sort of look at it each side of this addition sign. There are two big terms and expressions we can lump together as single units. And if we look at these two expressions, they both contain t minus 5 in it. And because of that, we can consider t minus 5 entirely, this whole expression, as our common factor between the two expressions. And by doing this, what we can do is we can say this f of t is really equal to, if we factored out t minus 5 first. From the first part of the expression, I would have left with t. And from the second side, that second term over here, I would be left with positive 6 over here. So I really have t minus 5 times t plus 6. And by doing this, you can see we turned f of t into the factored form. I have a product of two expressions. And from here, I can set this expression to be equal to 0 in order to find the horizontal intercept through zero product principle. And this process is called factor by grouping. Essentially, we grouped the entire expression into two groups. And as we do this process, we're looking at what does each group have in common as a common factor. This is what we're doing in this type of problem. And now if we look at this resulting expression, we can say either t minus 5 is equal to 0 or t plus 6 is equal to 0. Therefore, t is equal to 5 or t is equal to negative 6. And if we want to list the horizontal intercepts or our t-intercepts, we would have 5, 0 and negative 6, 0. We still want to list these points in ordered pair form because these are points and we want to indicate both the x and y coordinates for that. In this case, both t and y coordinates. Now let's take a look at another example that's slightly different. So if we look at part B, for f of x, we have x plus 8 minus 9x minus 72. And in this process, we basically deliberately break it into 4 terms. I know it's tempting to kind of group things together and combine like terms to do this process, but just for our purpose, we want to kind of keep them separate and think about what does it look like if we want to start from the beginning to complete factor by grouping. And here, if we want to complete factor by grouping, the first thing we want to do is again group the terms into two groups. And the first group we have is the first two terms, and the second group we have is the second two terms. And just to keep the signs a little bit simpler to keep track of, I'm going to group them into two groups and connect it by addition, because we know that if we do addition, the signs won't change in the middle. That way we can keep track of the signs later on as we look at individual groups. So here, if we do so, we can see f of x is really equal to, for the first group, it's just x plus 8. We can't really do much about the first group. It's already as simplified as it gets. Now for the second group, what we can see is we have negative 9x minus 72. And just within that group, we can look at what's the GCF between the terms in that group. And we can see negative 9 is going to be a common factor that we have. You can keep the plus sign in the middle that we added to connect the two groups, and we're factoring out negative 9 as a common factor from the second group. And as we do so, we can see as we pull out negative 9, we're left with x for the first term in the second group, and we would also have plus 8. Notice a sign change over here because we took out the negative sign as a GCF. And once we have done this, now we can see that we again have two groups just like what we had to start with in part A. And because we have this x plus 8 and x plus 8 in common, now I can treat x plus 8, that entire expression, as a common factor between the two groups. If I do so, what I can get is I can write x plus 8 as a common factor. And now if we think about what we are left with from the first term, or the first group, if I take out x plus 8, technically I took everything out, and I'm left with a factor of 1, because I know x plus 8 times 1 will equal to x plus 8. That's what we want in the first group. And now for the second group, if we factored out x plus 8, I'm left with negative 9 over here. At this point, you can write it as minus 9 directly if you want. And just to clear things up, we have x plus 8 times negative 8 over here. And you would have achieved the same result if you simplified f of x first by basically combining like terms and factor out GCF. But for our purpose, I just want to take the extra step. It seems a little longer process, but it gets us familiar with the process of grouping and practice with this idea of how we can group 4 terms into 2 groups and use GCF for factoring process. And once we have this form, we again want to set f of x to be equal to 0 for our horizontal intercept calculation. And if we look at the two factors, the first factor is x plus 8 is equal to 0, and the second option would be negative 8 equal to 0. Because we know negative 8 doesn't equal to 0, we don't really need to consider that option. And therefore, if we solve for x, we would get x equals negative 8. Therefore, the horizontal intercept, or the x-intercept here, will be negative 8, 0. That's the point. And lastly, let's look at the part C. And in part C, we have this case of quadratic function again, and we want to think about how we can use factor by grouping to find out what exactly are the horizontal intercepts. And first, I'm going to group things into 2 groups again. And here I already have a plus sign, but just to keep things consistent, I'm going to add a plus sign over here. And for g of x, we can really write this into 2 different groups. In the first group, we can see that they have some common factors we can take out. In particular, I have the factor of 5 I can factor out, and the lowest degree of x they have in common is x to the first degree. Once I do this, I'm left with x in the first term in the first group minus 1. Don't forget that minus 1 because we don't want to lose a term through factoring. And then we would have plus for the second group. We see a common factor of 7, and that's what we want to factor out from the second group. And we get x minus 1 as a result. And just based on this, we again have 2 groups, and each group essentially is in factored form. And in these factored form, we notice that they again have a common factor that's a expression with 2 terms in it. And with this, we can go ahead and factor that common expression out from both groups. Once we do that, from the first group, I'm left with 5x. From the second group, I'm left with positive 7, or plus 7. And the next step, we can see this is already in fully factored form. then we can use a zero product principle to make this equal to 0. And by doing so, I'm saying either x minus 1 is equal to 0 or 5x plus 7 is equal to 0. So x is equal to 1 or 5x is equal to negative 7, therefore x equals negative 7 over 5. And therefore we have the horizontal intercepts being 1, 0 and negative 7/5, 0. And we have two horizontal intercepts. As we expect, we can have up to two horizontal intercepts for a quadratic function.